Welcome hams, shortwave listeners, and makers. I'm here to introduce myself to you. My name is Richard Clark, KB7QHC. My roots go back a number of years. My first toying with amateur radio was in my high school days, summer jobs, working in television repair shops and such, one of which was owned by an amateur radio operator, had a full kilowatt sitting right there in the television shop, and boy, every time he hit the transmit button, all the house lights would dim. So that's a long time ago. What have I done in between? Well, I had to ask myself that question too, and it's a difficult one because I've had such a varied career through my life that without a list, I can't keep track. And to show on the back of this envelope, yeah, that wasn't working too well. Okay, so I'll just read them off. First on the list here is instructor. When I was in the Navy, part of my hitch was training electronics technicians at Electronic Technician A School on Treasure Island in San Francisco. That was in the late 60s, early 70s. I entered the ETA branch N, A3N, as an instructor, but as an ETR2, R being for radar. I was trained as a radar technician, so to speak. These are the two splits in electronics technicians, up until you meet it for chief. No, for first class? Yeah, first class. I was also a first class DT. No, later, after my instruction career, that's part of the list here. So I'll cut this to the quick. An instructor in A school teaching electronics communication gear, much like the equipment that you see behind here. I've also worked on flight recorders. Well, no, let me back up. I'm going to show off my certificates first. So let me switch over to, there we go. These are the various certificates that I've earned during my career. This is my first FCC first class radio telephone operator, issued in 1970. And this was on the heels of my having graduated from ETA school, the radar branch, and I got a ship radar endorsement down here. So this is still a prime ticket. Over here is its replacement when they went to lifetime granting. These two are from my A school and C school, as are some of these. These two here relate to a specialist school that I took through the Air Force at Lowry Air Force Base in Denver, Colorado. Let's switch back here. That was calibration school, metrology. So that's where I learned how to calibrate what's called primary and secondary standards of measurement. And that means it's a legal measurement. In other words, what I say is legally binding if it were evidence. And that would have been, at the time, I was part of the National Bureau of Standards laboratory system for maintaining and using standards and being certified as part of their network. Let's see. So, yes. So those two certificates relate to advanced microwave measurement and the primary standards of the ohm, the ampere, and the volt. And the various other farads, Henrys, measuring those out this many places, believe me. Out here at the, well, I don't, let's see, it'd be out at this end, at the 12th digit after the point. Okay. I have a little left or right problem on the screen here. So it's enough to say that I measured the ohm to the nearest millionth accurately, specified. It was that and nothing else, well, except for the noise. Voltages, similarly, 1 volt out to 6 places. Current, similarly so. You might notice that there's a standard limitation of what would be called accurate, and that's around 6 places at this stage of technology. Okay, so returning to my list here, now I get into flight recorders. I designed flight recorders for the 747, 757, and 767. The last two I did alone. The first one I was on a large team. Basically, this is where we're going to go to the second graphic. The flight recorder, or the black box, takes in a stream of data and stores it onto a magnetic tape. You might ask, well, how much data can that be? It's enough to render a graphic such as this. Here we see a really loaded graphic of a lot of curves, and they're color-coded against the scales that are either to the left or to the right of the graphic here. You might have to squint real hard, or perhaps expand your screen to see the scalings, what values are used. I'll give a highlight here, right here. Okay, so starting. This is time 0 at this corner right here, and this is sometime later. Let's see, about 2 minutes. About 2 minutes later, and this is a jet taking off. And I'm going to start at the bottom instead, because this is the altitude. Here we have the jet on the runway, going down it, picking up speed, and then lifting off. So there you see one sensor that my recorders were measuring, turning into a digital signal, and applying that to a tape for storage, just in case. The just in case here, TWA Flight 800, is responsible for this graphic of all the various airplane sensors that are recorded. We have the altitude here, we have the speed, you can see, and you can see there's a fair amount of noise in here. That is noise. We have here pitch attitude. That's kind of a, well, I don't know what it is. That's for airplanes. That's probably the nose lift. On this line here, that's elevators. So that's flat positions on air surfaces. Heading, almost dead ahead. Roll attitude, well, we're climbing and then we're starting to turn. Rudder position, well, left, right, left, right, left, right, left, right, smooth, smooth, smooth. Okay, we're up in the air. Rudder's perfect. Pitch, the stabilizers, they don't change at all. Angle of attack, boing, we're climbing like a rocket, and then we're settling out. Well, as far as aggressive climb. Here we have 4 engines showing how much thrust they are generating. Here is a vertical acceleration, or lift. We have to have lift to fly, and but it only comes in jerks and dips and gains. So this is what you see is it's kind of the bouncy of the ride. This one up here, longitudinal acceleration, that is more to the matter of, well, I can't really say. I'm not an avionics fella. I just design the electronics. And at the top is a simple on or off mic key from the pilot's in the cabin. So, returning to returning to the shack. That's all the graphics I'm going to send your way. The list, I could add graphics to that, but this would be a 3-hour marathon. So, flight recorders. I've done flight recorders. I know flight recorders. I know all the data streams, that is the linear voltage, and it's all linear voltages that I digitized and turned into a data stream. I've developed oximeters, much like the finger clip thing that you use to check your O2, 97%, 98%, that kind of thing. I was doing that back in the mid-'80s. I spun that up into just a generic O2 sensor for measuring production chemistry on the fly using fiber optics and a specialized rare element at the end. Well, it's not a rare element, but it's a costly product. It's called porphyrin. We won't go into any further there. I worked on measuring the Stroud moment of Army helicopter pilots to test their alertness, so I built a mechanism that they would look into to see flashing lights, and when those lights merged, that was an indication of how alert they were. If that was a very low frequency, like 10 hertz, you're probably blind drunk. A good alert pilot would be about at least 30, well, basically what would be 30 frames a second, or 30 flashes a second. That's where you get what's called flicker fusion, where the eye ceases to see individual occurrences, but merges everything into one composite experience. So that's called the Stroud moment. I've already told you about doing calibration. That was part of my schooling. I did that both in the Navy and outside of the Navy. Worked on torpedo sonars, and that wasn't in the Navy. That was for Honeywell, and I did that twice. You can get wet doing this kind of stuff. Speaking of getting wet, I designed an inkjet printer for a production line so that it could spray a label on a passing box. Things can get pretty exciting when your spray head bursts into flames. That's where we get into lessons of heat management and circulation and similar stuff. It's an interesting field that I'll introduce to you later when we get into the discussion of 50-ohm dummy loads. It's something that's just occurred to me that is going to be a good first principles kind of topic later. I've worked on central office equipment, that is telephone, at the other end of the telephone, not the one that you pick up. I also worked on that kind of stuff, but that's pretty well established for the past 150 years, it seems. However, the switching equipment is remarkable in its relay logic. So I know a world of relays, believe me. Moving on, I've also done SCADA, that's supervisory control and data acquisition over the power grid. What I did there was designing a protocol analyzer that would where you could get a readout of say a query of the system and read what switches were open, which were closes, status of a local grid. I've also worked on high-speed printers, very high speed, like 20 to 30,000 pages an hour. Yeah, I guess. It's been a long time. I've worked in the electronics for measuring blood pressure in several ways, and this is going back to the era of where when you went to the drugstore, there was a little booth there that you could slip your arm into. I worked for those people. I helped them with the software. Didn't do any sensor design there, but software. Then, let's see, all of this is by virtue of my having been what today is called a gig worker. In my day, it's a contract. So I have many, many, many contracts here. One I worked on was organ perfusion. That's a situation where you're moving donated organs from one place to another, and it takes more than just an ice cooler and a bucket of ice to take care of things. They have to be, the organs need to be basted, so to speak, from the inside. So it's a complex issue. We'll move on instead. After that, I designed a PDA warehouse, personal digital assistant. This is about 1990, when we were breaking grounds in doing this using spread spectrum. So that was early heroic work that, boy, there was a lot of work going into all the issues that I'll discuss here in the macro scale and at the micro scale of the plumbing, of making connections, amplifier matching, antenna design, that kind of stuff. All of that was part and parcel to the project that I was working on. This was a personal digital assistant that was already Wi-Fi, well, not Wi-Fi, but this is long, 10 years before Wi-Fi. Okay, that's crowing, so moving on. Developed precision scales for weighing cars in a racing environment. So these were pads about like this that were measured to an accuracy of 1/10 of a pound. And that's pretty good when you're talking about the pressure of the wheel on the road being typically between 500 and 700 pounds, somewhere in that region. I also worked on designs for an EPA noise monitor for aircraft or airplane, well, actually airport noise. So this was during the noise abatement developments of the 1970s. I also worked on an esophageal pH meter. So, measure the pH of your esophagus. Well, this is during surgery, so there's a lot of other things going on there too. And to round out my list, I've kiln control. Can you imagine going from an esophageal probe to kiln control? Kiln, what's a kiln? Kiln in the Pacific Northwest here is, the purpose of kilns is to dry wood. Well, this is a wood-based product region here. It used to be pretty healthy, but that moved to the southeast, Georgia. But in our heyday, we had labs all over the place, and I was part of those labs and measuring paper, the whiteness of paper, the brownness of cardboard. Yes, there's numbers for those. And let's see, and the drying of wood. It's a complex thing. I learned a lot about relative and specific humidity. So, goodness, I don't know how many minutes this has been running on, but I think I'll just wrap it up there. I won't get into, I'm probably the only engineer that you've ever come across that has a degree in English and a degree in cinema. I don't have a degree in engineering. They asked me if I could do it, and I said yes, and I did it. They paid me well. So it's time to stop. So thank you for joining me here, and I hope you enjoy the material that I have to present to you. So, 73s.